Okay, today's lesson is chapter 3 in your book, page 48 through 51. So fill it out as we go through it. So on the top of page 48, kind of review multiplication. We did that in chapter 2, so you can look over that. So on the activity on the bottom, on the number line below, show a length of 1 unit. Then make the length of 3 units. So I'll just put this distance is 1 unit. So now I need to make 3 units. So there's 1 unit, and then 1 unit over here. So there's 3 1-unit segments. So on the next number line, we're going to show a length of x units. X is just an arbitrary length. This distance between these two tick marks, r, is x. Now if I want to make 3 x's of the same distance, I just have that. So keep that in mind as we go through these next examples. So turn your page to page 49. So this talks about area as a representation for multiplication. You should have seen this before, but we'll talk about it again. So on the top it has 2 units times 25 units, and then the area, or the answer, is 50. So 2 times 25 gives me 50. That is a representation of multiplication. Okay, the same thing for representation of 50. We have 5 times 10. My area is still 50, even though it looks different than the previous example. Okay, this next one, we have 5, but on the top we have the 3 and the 7. But when we add these together, we get 10 units. And it doesn't matter that they're broken up into 3 times 5 is 15 and 7 times 5 is 35. When you add those up, you're still going to get a total of 50. So even if there's grouping symbols, like here, so we have 5 times 3 plus 7. That just means we have 5 groups of 3 plus 7, or 5 groups of 10. And that means multiplication. So this same example, or this other example down here, we have 5 on this side, but then we have groups of 5 and 5. Notice we get 5 times 5 is 25. And then if we add the other 25, we still have an area of 50. Nothing changes, it's just we have 5 groups of 5 plus 5. Or 5 squared times 5 squared. How they get that is they do the distributive property, which we'll talk about. But it's 5 times 5, and then you keep the plus sign. 5 times 5 again. So create your own representation of 50. And I'll let you do that. So I want to draw an area model for the representation of 3x. So this time we have a letter, but the process is just the same. So this is 1 unit, and this length is x. It doesn't matter what x is. This next block has 1. Same thing again. So now I have 3 on this side, and I have x across the top. This whole distance is x. So this is an area representation of 3x. Okay, go to the next page, page 50. We're going to model 5 times the quantity x plus 1, and then we're going to simplify and justify each step. So we are going to draw a model. And there's lots of ways to do this. So this is just one example. So I have this unit is x, 1, and then this unit, so this is still 1 times 1, so this unit represents 1, and this area represents x. But I need 5 of these, so there's 2, 3, 4, 5. So this is a model. To simplify our expression, we need to combine. So we have 5 x's, and they're all positive, and then adding 5 1's together gives me 5x plus 5. That is simplified. To justify your steps, I have 5 x representations and 5 1 representations, and I added those up. We cannot combine x or 5x and 5 because they're not like terms. One has an x and one doesn't. And there's other ways below that you can represent that as well. So for number 2, we're going to make 4 groups of x minus 2. So this represents x. This is distance 1. This is distance x. For my negative 2 units, just remember, we're going to be highlighting them for negatives. Negatives are highlighted. So each of these represents negative 1. 1 unit. 1. Okay, so I need 4 of these groups. So I'll take a second and draw those. And then these are all x and negative 1's. And they should be highlighted for negative. So I need to simplify. So I have 4 x's that are, there's no zeros pairs. They're all positive, so it's going to be positive 4x. And I have 8 negatives, so I'm going to have negative 8. You could also write this as 4 plus negative 8. Either way is fine. Okay. Now I'm going to write 4 times the quantity x minus 2 3 different ways. And they all mean the same thing. So we can use the distributive property, which means multiply. So I'm going to have 4 times 1 is 4, and then add the variable. And then I'm going to have 4 times negative 2 is negative 8. That is one way to change 4 times the quantity x minus 2. Another way to change it is I have 4x plus negative 8. And then I could have 4 times x, I could write it like this, plus 4 times negative 2. Those are just some different ways that you can think about it. This is the distributive property. So what does the number in front of the parentheses tell you about grouping? About the grouping? About what's in the parentheses? How many groups you have. So turn your page to page 51. If you need to use models, feel free. I will be using algebra. So this is called the distributive property. So when I have a number and then the parentheses, but in the parentheses I have an addition or subtraction, okay, because I cannot combine x and 2. They're not like terms. So we can't combine them, so how we get rid of it is the parenthesis, the distributive property. So you take 3, and remember there's an invisible 1 in front of the x. So I have 3 times 1, which is 3, and then we bring the variable. So we're going to distribute, so we're going to bring down the plus sign, and 3 times 2 is 6. And then I cannot combine any further because there's 3x and positive 6. This is simplified. And if you need to draw a model, feel free to draw a model. And we're going to do number 7. I'm going to have 4 times the quantity x, 3x minus 1. In the parentheses, I cannot combine 3x and negative 1. They are not like terms. One has an x and one doesn't. So I'm going to use the distributive property. So it's going to be 4 times 3, the coefficients, so that's 12, and then don't forget your variable. Now I'm going to do 4 times, well, bring down this, negative 1, so 4 times 1 is 4. Okay, I cannot combine 12x and 4, they are not like terms, one has a variable, one doesn't. So example 10, this one has a fraction, but it's the same concept. Timesing by a half is the same as dividing by 2. Whatever way you want to think about it is fine by me. So we'll be doing the distributive property because I cannot combine 4x plus 6. So I'm going to have 1/2 times 4 over 1. And for multiplication of fractions, you multiply the tops and the bottoms. Simplify. So 4 divided by 2 is 2. And then I'm going to bring the variable. The sign just comes down. I'm going to have 1/2 times 6 over 1. So I'm going to have 6 over 2, which reduces to 3. So I'll erase this so I can do example 11. Also a fraction. So we have 3/4 times the quantity 2x minus 5. We cannot combine this. One has an x, one doesn't. So I'm going to use the distributive property and multiply. So I have 3/4 times 2 over 1. Multiply the tops. 6 over 4. Always simplify your fractions. I'm going to divide by 2, so 3/2. That's the x. Minus sign. Now I'm going to have 3/4 times 5 over 1. So 3 times 5 is 15. 4 times 1 is 4. To simplify that, I'm going to get 3. Oh, just kidding. Sorry. That's simplified. 15 over 4. So then I'm going to minus 15 over 4, and there's no variable. This is the simplest it can get. This one has an x. This term doesn't. We cannot simplify any more. So the last question on this page, in 6th grade, we talked about order of operations. What is the order of operations and how is it related to what we've been doing? Order of operations, you may have remembered, it's grouping symbols first, then the exponents, adding, subtracting, or multiplying, dividing left to right, adding, subtracting left to right. So how this is related to what we're doing here, when you're simplifying expressions, you still do the same thing first. I'm getting rid of the parentheses by the distributive property. So it still works. We're still doing the same thing. The only difference is in the parentheses, I can't simplify that first, so I do that by distributing.